Hello dear student, today we learn about a simple assembly scheme. In that we learn about a 4-step approach to develop a design specification of an assembler containing these 4 approaches. The first one become identify the information needed for performing a task. We know that during the assembly process, during the assembly language process, there are 2 phases are there, analysis phase and synthesis phase. So which information is required during the analysis phase and which information is required during the synthesis phase. So we have to determine which information is needed during which task. The second one is design a suitable data structure for recording the information. Means after analyzing the information, which data structure is required to store that information. So this is our second point. And then third one, determine processing needed for obtaining and maintaining the information. Means for getting the information during the analysis phase and synthesis phase, also how to process that information, like how to store that information, how to retrieve that information. All these are determined during the third step. And fourth one, determine the processing needed for performing the task by using the recorded information. Means during the first, second and third step, the information we are gathering, and after that we construct a data structure. Then how to use that recorded information, means how to use that information contained in that data structure to assemble the program. This is our fourth point. Now when we are considering the assembly scheme, the assembly scheme is contained 2 phases. The first one becomes a synthesis phase and second one becomes a analysis phase. When we take it step by step, after analysis phase synthesis is performed, but firstly we go for the synthesis phase. Which tasks are required during the synthesis phase. So for that consider the example. Here move r breg, 1. This one instruction is given. Here move r is what? Move r is nothing but a mnemonic. And BREG is what? BREG is nothing but a first operand. And 1 means what? Your symbolic name. Means here it's your second operand. Means move R becomes your mnemonic and BREG is our first operand and 1 is our second operand. So how this statement is synthesized during the assembly process? So for this what we require? Means which data structures are required there, also which information gathering is required there. Now when we considering the statement, here we say that the first move R is a mnemonic. Move R is what? Move R is a mnemonic. After that BREG is a register and 1 is nothing but it's a symbolic name. So which type of data structure is required to store this information? So to store this information, 2 types of data structure are used. The first data structure becomes your symbol table and second data structure becomes your mnemonic table. So what is mean by symbol table? Also what is mean by mnemonic table? Who construct this table? That we see. That we learn here. Now here what is mean by symbol table? See, when we are considering this statement, move r breg, 1. Here 1 is what? 1 is a symbol. So when such type of symbol appear in program, at that time what the assembler do? It will create one symbol table and in that table each entry of symbolic name is get done. So how that entry is given here? So for each symbol table, each entry has the field name and address. Means if here considering this statement, 1 symbol is appear, means this 1 symbol is taken, it is given in the symbol table name field and the address of that symbol 1 is taken and that given in the address field. Means in this way the symbol table contains two fields. First one becomes the name and second one becomes the address. Means whenever any symbol appear, at that time the symbol entry is done in the name field and the corresponding address of that symbol is done in the address field. So who construct this table? The symbol table is constructed during the processing, because when the symbol appear in your program, at that time only the symbol table is constructed. Then second data structure is mnemonic table. As like symbol table, the mnemonic table is constructed by the programmer of the assembler. Means a mnemonic table is given for us by the programmer, means the developer only, because when we are using the mnemonic, some corresponding opcodes are specified there. So that corresponding opcode is specified by the developer of an assembler. So the mnemonic table contains three fields. The first field becomes mnemonic, second field becomes opcode and third field becomes length. Okay, means the second data structure is mnemonic table. Mnemonic table contains three fields: mnemonic, then opcode and after that length. Means if you are considering that MOVR is what? It's a mnemonic. So MOVR entry is performed during the mnemonic, and after that which the corresponding opcode of this mnemonic, that we learn in our last lecture. Means some particular mnemonic is assigned, some particular mnemonic opcode is assigned for a mnemonic. So suppose considering that 07 is used for the mnemonic MOVR, then entry is performed like this: mnemonic is your MOVR, then corresponding opcode becomes your 07, and how much length is required to store that statement. Means this statement require how much storage memory, so that length is specified here. Means each assembly statement require a particular length to store that one, means some 1 byte, 2 byte, etc. If the statements are declarative statement like DS and DC statement, at that time the length will be depend on the constant specified in the DC statement, otherwise DS statement. In this way symbol table and mnemonic table entry perform. Means the symbol table contains two fields, name and address. Whenever the symbol appear, the entry of symbol is done in a symbol table and the corresponding address is given in the symbol table. And in the mnemonic table, three fields are there: mnemonic, opcode and length. The mnemonic means like MOVR, the corresponding opcode of that MOVR and the corresponding length of that statement. In this way the synthesis phase perform the operation. Now when we are considering that here in symbol table, once the symbol is found, then after that name is given here and after that address is given. So who determine this? Means which address is given to which symbol, which address is given to which symbol. So this task, memory allocation task, is performed during the analysis phase. Means the memory allocation task is performed during the analysis phase. Now how the memory allocation task is performed? Now considering that, suppose in a last lecture we learn about one example of addition of two numbers. In that we are taking one variable like n1 and n2. Now if we are taking the address of n1, how we generate the address of n1, how we generate the address of n2? So the assembler gives the address to that corresponding symbol n1 and n2 after allocating all the instruction that given above to that symbol. and then the next address is given to N1 and N2. Means from where to start to give the address. See, consider that the one assembly program is given and it is start by the which statement? Assembler directive start statement, and in that start and after that some specific constant is given there. Means start and some specific constant is given there. That is nothing but we are considering it as a address to store the first instruction of that assembly program. Means suppose in a start statement you are given like start and 200, then the first statement after the start is stored at the location 200, means it start from the 200 because in a start we specify 200, and after that the next instruction is given address as 201, 202 like this. Means in this way all the instructions are given the corresponding addresses. Means in this way the address is given there. So to give this address one location counter is there. Means the location counter is perform the functioning of memory allocation. Location counter will perform the functioning of memory allocation. Means when the start statement appear, at that time your location counter is represented by in this way, location counter. Means when the program start, at that time your location counter is set by the address which is given in the start statement. Suppose your start statement contains value 200, so that 200 value is specified, is assigned to the location counter 200. Now what the location counter do, how it perform the memory allocation activity? The location counter checks the statement. Means after checking the statement, it checks the mnemonic table, means how much length is required to store that statement, to store that instruction. So depending on this length, the location counter increase its value. In this way, for each instruction the location counter generates some address. Means for each symbol it generates the address. And suppose some statement appear which contains a label, at that time what the location counter do? It will take that label as a symbol and take the location counter value, means the value which is present in the location counter. So the name, symbol name and location counter value is taken by, and after that the entry is performed in symbol table. Means in this way the memory allocation activity is performed by using the help of location. This figure shows the data structure of an assembler. There are two phases are there, analysis phase followed by synthesis phase, and during these two phases some information is gathered, like we learned previously. Means information is gathered, and to store that information a particular data structure is used, like a mnemonic table and symbol table. Now see here, analysis phase is there and synthesis phase is there. Firstly the source program is given to analysis phase, and in analysis phase generate the symbol table. Okay, analysis phase generate the symbol table, and then this symbol table is used during the synthesis phase. The symbol table contains two fields. As we learned previously, the symbol table contains two fields, symbol and address. Means whenever the symbol appear, whenever the label appear in the program, then that symbol is taken, its entry is performed here, like symbol is given and the address contained in the location counter is taken and the address is store here. Means in this way entry of each symbol is done in a symbol table. And the second data structure is mnemonic table. The mnemonic table contains three fields, the mnemonic, after that opcode and length. Mnemonic like this add and sub. the corresponding mnemonic opcode and length. See, here the mnemonic table is used during the analysis phase also and during the synthesis phase also. Means the mnemonic table is used during analysis phase and synthesis phase also, because the mnemonic table is specified by the developer of an assembler. Means here during the analysis phase, the mnemonic table is used to determine how much memory is required to store a particular statement, means by finding the length of that statement.